Ever wonder how to find the inverse of a function? Let's explore this together. Hi, I'm Dr. Finch. I have a PhD in math and over 20 years of experience in education. Before we get into our problem for today, let's remind ourselves what an inverse function is. So an inverse function, and I will say that the definition I'm giving you here is more of the layperson definition. There's an official one that you can find in any textbook. In this case, we're going to say an inverse function undoes the work of a function. So anything it does to modify the x that you feed to your function, an inverse function is going to undo that. So it spits out the original x back to you. So for example, if we are looking at f of x is equal to the cubed root of x, then our inverse function, if we want to undo that, and our inverse we write as a -1 up as a superscript behind our f, the opposite of that would be taking our x value and cubing it. So that means when we feed our inverse to our function, we get x cubed, and then we're taking the cubed root of that, we get our x back. We also might notice that f inverse of f of x is the cubed root of x quantity cubed, so we're going to get x back as well. Not all functions have inverses, so we do have to be a little bit careful of that. And there is a process to find the inverse of a function. That little superscript that we see there that you notice. I'm going to just do it this thing right here. Notice it doesn't mean that you take 1 over your original function, right? If we did that, our original function here is cubed root of x. If we just put 1 over that, we'd have 1 over the cubed root of x. Those are not inverse functions. We're using the word inverse slightly differently than the way we use it as a fraction. So it's just a little bit different. All right, before we get back to our problem, if you have a question that you'd like to see answered or a topic that you'd like to see covered, please email me at purplefinchmath@gmail.com. I'd love to hear from you. Thank you. All right, so back to our problem. We have the function f of x is equal to 3x plus 2 divided by 4x plus 5. This one is going to be a little bit tricky. We're going to go through 4 steps here. Our first step is we are going to replace our f of x with y. This is just going to make our lives so much easier if we do this. Less work is always better when we can do it. So y is equal to 3x plus 2 divided by 4x plus 5. Second of all, we are going to switch all, oops, there we go, x's and y's. Oof, that sounds like a lot of work, doesn't it? All right, so there's a y, there's an x, there's an x. Everywhere you see a y, turn that into an x. Everywhere you see an x, turn that into a y. So this might actually take a little bit of work in the sense you aren't just moving 2 letters around, right? All your numbers, everything else stays the same. We are just switching the x's and the y's. All right, now that we have that, ooh, this looks a little bit gunky, doesn't it? We are going to solve for y. How do we do that? Okay, we got 2 y's and they're in a fraction. So one of the things that we like to do when we're dealing with something like that is get rid of the fraction. Ugh. Okay, so the way that we're going to do that, and I'm just going to do that step by step so that we see everything out, is we are going to start by multiplying by our denominator on both sides. Remember, if you have an equality, what you do to one side, you have to do to the other side to keep your equality. All right, if we do that on the right-hand side, those items cancel out, which is nice. And we're left with a 3y plus 2. This looks so much better. Everything's on one line. You got rid of the fractions. We don't have that. Everything's cute and pretty. All right, except for we've got this multiplication here. So let's actually multiply that x out. We're going to distribute that. So we get 4yx plus 5x is equal to 3y plus 2. All right, and I am actually going to just copy that. We're going to go to the next page because we are running out of room. We're going to paste. All right, we still want to finish solving this. Now you'll notice that, oh, we still have, now we got some other stuff going on here. And I will say, before actually we do this, I'm going to go back and do one thing. I want to remind you here, and this is going to be key. This is what I've seen a lot of students here. Do not divide by x. I think this deserves a triple exclamation point, because this happens a lot, is students will see this. We have two things multiplied. We want x's on the other side, and then they decide to divide by x. And then you've got y's and x's on the one side, and you can't really pull that y back because you've got 3y divided by x, and it just makes a mess. So we're going to avoid that x or that problem by not dividing by x, but instead distributing that x. And now what we're going to do to solve this, and actually let's just separate x's and y's. Anything with an x or anything with y, let's put it this, anything with y on the left-hand side, I'll abbreviate that with LHS. Anything without a y on the right-hand side using addition and subtraction only. So no division yet. We do not want to divide yet. So let's get down to it. We are going to, let's subtract 5x on both sides here. So this gives us 4yx is equal to 3y minus 5x plus 2. Let's get rid of this 3y. That has a y, so we're going to move that over to the left-hand side. Okay. Okay, that looks a little bit better. Notice we have one copy of y in each term here. We have a little y here, and we have a little y here. So what we're going to do next is we are going to pull the y out of both terms. So we're going to do the opposite of distributing something. We're going to factor it out instead. When we pull a y out of our first term, we're left with 4x. And then minus, pull a y out, we're left with a 3. So now we have a negative 5x plus 2. So now here's what's nice. Once we get to this point, we have y times a whole bunch of stuff that has no y in it is equal to something without a y in it. So the last thing we're going to do is we're going to divide out both sides by that extra stuff. And we end up with y is equal to negative 5x plus 2 over 4x minus 3. So there's our solution. Now we have one last step to take, and this is the one that is often forgotten. Hopefully your teacher is kind about this, and if you forget the step, only docks you off a point or something. And that is to replace our y back with an f inverse of x this time. So this isn't our original function. This is our inverse function. So we're going to have that negative there. Negative 5x plus 2 divided by 4x minus 3. So there's our final answer right there. So pretty. Notice this looks very different from the function that we first started off with, but it is beautiful in its own right. Thank you so much for listening today.